It was a teacher I shall not name. All right. So, bust out the note packet. Like I said, everything that we do in class is part of your daily work. I want to spend more time doing examples in class than here's two examples, okay, now work. I would much rather give you an assignment that's like 15 minutes or so, and that's it, but we spent a boatload of time in class making sure we got it. Okay? So, that means everything we do, every example, everything we're writing up here goes in your notes, because you will turn those in with every quiz. So if you turn this in and there's like entire slides or chunks or problems missing, it counts against you in terms of your completion because you didn't do the thing we did in class. Okay? That's it. Just follow along. In the past, I've kind of given kids an option. Do you want to do your own notes in a book or do you want this? And over time, kids were didn't. Just give it to all of us. Why aren't you just giving this to all of us? It's easier. Okay. So, there you go. The beginning here, like I said, the first 3 chapters of your book, actually the first like 3.9 chapters of your book. It's like 3 in a nubbin, okay? It's all review. Every single thing that we're going to do for the next couple weeks, other than maybe a little bit with transformations, a 3-variable system here, like a couple of days here and there, it's all review. So if it's been a while since you did Algebra 1, don't worry about it. We got you. Now, out of curiosity, I know Algebra 2 first semester is always kind of runs the gamut between sophomores, juniors, maybe even a couple of seniors. Where's my sophomores at in here? Okay, mostly juniors, handful, seniors. Okay, so we get this weird dynamic where some of you probably had Algebra 1, what? You might have had it first semester last year, is the earliest, the nearest to this point in time that some of you would have had it. Otherwise, you're looking at least a year, at least a full year, if not a year and a half, 2 years. And the reason I'm comparing to Algebra 1, not geometry, is because they're completely different animals. In fact, other schools, they'll actually say that from Algebra 1, you can go straight to Algebra 2, not geometry. Like you get your choice. You take Algebra 1, that's the prerequisite, then you get to go to either geometry or Algebra 2. The first school I worked at, you could do them concurrently if you wanted. So I refer back to Algebra 1 because that's what we are worried about. We want to know that you understand how to do Algebra 1 because we're taking all of those concepts and expanding on them. The first couple of weeks, the first 3.9 chapters are all about, this is stuff you did, review it, maybe put a little sprinkle on it, got the meme, right? Getting that little salt on there. And that's it. But once we hit the end of chapter 4 and we start talking about imaginary numbers, then we get into polynomials, complex roots of polynomials, and we start going further from there. Okay, now we're all talking new stuff. So bear with me. In the beginning here, we might do stuff that is so boringly obvious to you, but maybe someone else hasn't had algebra half for 2.5 years. So when I ask which of these expressions is correct, how do I translate words into math? Maybe some of you are just like, why is this even a thing? Why are we doing this? And someone else goes, oh, crap. Okay? So what do you think? Naturally, you would want to be a native English speaker for this to work the best. Sorry. What do you think? 7 fewer than the number t. Okay, so we hear 7, we hear t. Yeah, they all got that. Fewer than. Fewer means smaller. I know that subtract is involved. But how do I know that it's C and not D? What is, literally, there is a word up there that tells me it has to be C and not D. Then. Then. Whenever I hear fewer than, more than, greater than, lesser than, it says put this at the end of. No joke. Y'all gonna hate this, especially juniors who had to deal with all the grammar stuff in English 2. Math has a direct grammar correlation to English, where when I hear the word then, it means put at end. No joke. It means put it at the end. Okay, so it's just one of those little tricks that we got to remember. So I'm guessing we're probably okay with all of the old school words. If I said, what are a bunch of words that mean I'm going to add stuff? Give me the English. What are words that mean I add things? Greater, plus, increased, more than, added to. Okay. What are the two things that you add together to make a result? The result is called a sum. What are the two things you actually add? Numbers. Hopefully. Sometimes they're variables. Addends. Addends. Okay. So maybe we got to knock a little rust off the gears. I guarantee you have, because it's a standard in multiple grades. I can go back and look at the standard list, but I'm pretty sure that's like a 3rd grade standard. Try it again. Now, whenever I do a thing and then say, okay, I want you to work on these, I don't want my room quiet. I want you talking to your neighbors. I want you arguing.
There's no other way.
What do we think? Okay, I heard a G and an H. It is H. Okay. So here's how this works when you actually sketch it out. You're not going to like this, but you remember diagramming sentences? Like underline subject once, predicate twice, all that kind of stuff? Okay. Okay. You can actually diagram this. When I see 2 times, 2 is a number. Times means I will multiply. When I hear the words the sum of, every time you have an operator next to of, it means throw parentheses here, look for the and in between them. So when I hear the sum of, that tells me to throw parentheses there. Sum of, product of, difference of. Whenever you have that operator word next to of, it literally means throw parentheses around what we're about to do. The sum, it tells me the thing I'm going to do is add. The and tells me these are the two things that I am adding. Okay, you can actually diagram sentences to turn into math. Did any of you ever do this?
Definitely not. This is the first time.
This is like algebra half. You never saw that? Okay, the first half of algebra. Oof. Okay. All right, let's try it again. So now instead of just direct words, now there's a little bit of context to it. You start with 20 bucks and save $6 each week. What's that as an expression? What operations do you know are happening there?
Multiplication and addition.
Okay. When I hear this is an amount and save. Save is something that increases an amount. So I know that I'm going to add things. Okay? This thing plus this thing. What are the things that I'm going to add? What do I start with no matter what? I know I start with 20 bucks. $6 each week. Whenever I hear the word each, and these put this in the margins or something if you need to. The word each means I will now multiply or divide. The multiply or divide depends on the context of whether it is getting larger or smaller. If I have $6 each week, am I breaking that into 6 groups or am I gaining 6 groups? Gaining, so that means I'll multiply them. $6 each week. How many weeks? So when I don't know in math, we put a variable. Okay? I put W for weeks because it correlates back to the problem. You can use whatever variable you want. A variable is literally just a placeholder. You don't have to use 6W. Like you can, I don't know. You can use. You can do 6 turd. It's just a symbol, right? It's a symbol that holds place. Maybe that you're talking about, I have to go to this job I hate. So you're going to use that as your placeholder. Okay.
So can I do that on a test and it'll be counted, right?
If you do it throughout the entire problem and you define your variable. Okay, no, that's a good one. That's a good one. Can I do that? Yes. If you define your variable. That's something I hadn't done yet. I need to, next to this, write turd equals number of weeks. Yes, you can do that. I would recommend not using like the eggplant, but that's cool. We'll tell you when you're older. Okay? Your turn. Looks like a phallus. A wiener, dude. Y'all need a bigger vocabulary.
I don't know. I definitely got it.
You don't think I can make that? Do I have permission to try to make this?
You got to pick it up if you don't.
No.
Okay.
150 minus 2x.
You had 150, you're spending $2 each day. Again, I'm starting with an amount. Spending decreases what I got. $2, and I see that each again. And then maybe next to it, I'm going to define again D is days. We should probably get in that habit now. And you know what? I'm bad at that. I forget to put my label next to the things all the time. Define your variable. Yes.
Do we have to do that on a test?
If it's in the instructions. If I didn't put it in the instructions, that's my fault. Why should I count it wrong on yours if I didn't put that in the instructions? Loophole. Okay. All right. Then we learned about evaluating expressions. Remember evaluating? Evaluating means I have this expression, I have these variables. These variables are placeholders, and then I replace the variables with a value. Evaluate. Maybe make a note to yourself right now. Yo, come on. Rewrite the expression with parentheses in place of every variable. Get in that habit now. Because you might be able to do something just fine on your own mental math. You might be able to just sneak the number in there and be good with it. But we will get things that are more complex to the point that if you don't put parentheses to evaluate, you're going to screw up negatives and exponents. I guarantee it. So I would rewrite that as 7, a parenthesis where the A was, plus 3, a parenthesis where the B was, minus 8. I would do that and then plug in my -4 and my 5. Right now, that might seem kind of overkill. You're going to want to know how to use a jackhammer at some point. Okay? Sometimes you might need overkill. Otherwise, you ain't getting through it. If I just gave you a sledgehammer and said, here's a pair of old concrete stairs from the 60s, I need you to bust that up so I can make a new deck. Do you want to just sit there wailing on that for the next 2 days? Or would you rather have the appropriate tool? Okay. Now, what comes next? Y'all remember, order of operations. PEMDAS, please execute my deranged adolescent sister. Please execute my deranged adolescent sister. I had a kid came up with that years ago, and it was too good to abandon. Okay. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. There's a problem with this, and there's one that teachers don't really specify too much in the middle school. I dislike that. This is missing stuff. You're like, no, that's what I learned. Side quest. What's the answer?
18.
Definitely not 18.
Oh, wait, no.
Oh, yeah, it is.
It's not.
No, because multiplication and division are equal. You go left to right.
Keep arguing.
0.2.
Multiplication. No, it all runs left to right first.
You're the same.
Same with addition and subtraction.
Okay. What if I wrote it like this? What if I wrote it like this?
It's still the same. No, it's because then you would do.
Oh, because
Oh, wait, it's not.
it's 3 times 6. It's definitely 8.
No, that's just you got multiplication
Final
It would be
answer.
12 divided by 9.
18. Final answer.
Dance, puppets, dance.
Second one because you do multiplication first.
It is 18. Okay. Okay, no. Now you see how heated some of you got about this. This is, in the math department, we call this Facebook math. This is when you will get like 40 and 50-year-old adults arguing with each other on social media about what the answer is, calling each other idiots. And worse, yep. The difference is, now, when I wrote it like this, I heard the magic words. I heard someone say, well, now it's as a fraction. There is a difference between this and this. There is a difference. Because when I have the full bar of a fraction, it implies parentheses. It implies parentheses. But if those parentheses aren't actually there, kids get mad about this part too, division and subtraction do not exist. They're a lie. Division and subtraction do not exist. Division and subtraction do not exist. They are not defined algebraic structures. If you go far enough in math, you take a little course called abstract algebra. In fact, it's the capstone course to become a teacher, where you prove why math works. Literally, the whole class is just prove why math. And part of it is defining an algebraic structure. An algebraic structure has to be something that has specific rules. It has to abide by these rules at all times. Addition and multiplication follow specific rules, like, you remember the commutative property? The order that I multiply in doesn't matter. 5 times 3 is 3 times 5. Those properties define the structure. If I said subtraction, is 7 minus 3 the same as 3 minus 7? No. But if I said 7 plus a negative 3, negative 3 plus a 7, now it works. So, because of that, I need to take this and rewrite it. Do you remember? Yes, dividing by fractions is easy as pie. Flip the second and multiply. Okay, that is not 9 divided by 3. That is 9 times 1/3. So, next to this, if this got you, if this made you even question for a little bit, right next to these, I would like you to write left to right. Left to right. Like a book, in the order that you encounter them. Okay? Please add those in. Because there is no such thing as divide, there's multiply by a reciprocal. There's no such thing as subtract, there is add the opposite. So, now that we got order of operations out of the way, what do I do first? Parentheses first. Which is 0. Now I have multiplication here and here that I could do simultaneously. 7 by 0 is 0, 3 by 5 is 15, 15 minus 8, 7. Okay? I'd like to see if you can do that whole business when there's a fraction and an exponent involved. Give it a whirl. I have not seen a person who didn't have gray hair eat Charleston Chew in like 20 years.
My dad loves that.
Respect.
I have no idea. 1.
Oh, yep, got it.
Did you rewrite it with parentheses first?
Yes.
Even if it's easy, get in that habit now so it doesn't screw you up later. I want you to think back to the quadratic formula. Okay, where to go? There, top row, fourth from the left, quadratic formula. How many of you screwed that quadratic formula up every single time? Like, I always ended up with the negative under the radical when I wasn't supposed to, and the calculator kept telling me to quit. Okay, parentheses. It was because of parentheses, I guarantee you. So please, get in the good habits now. X is a 1, Y is a 1/2. What happens when you square a fraction?
It's 1/2 times 1/2.
We know what exponents are. You treat that exponent almost like distribution. They both get squared. Half of a half. Think of a pizza. Cut it in half. Cut it in half again. What's each piece worth? Half of a half. So this is 1/2 plus 1/4. If you called that 2/6, we got problems. First of all, I still hate the person who came up with the word sixth in English. That is entirely too many consonants next to each other. Sixths. Don't do that. This plus this. You're teenagers. I guarantee at some point you have argued with another person over who gets what slice of pizza.
True.
Because they're different sizes.
They took my cheese.
Okay? Like, because we all know the folks over at Little Caesars can't cut a pizza straight to save their life. You get one slice that's like this, and another one that's like that. Okay? These are not equivalent, so you have to make them equivalent. You make them equivalent with common denominators. Remember that?
Yes.
Got to have common denominators to add and subtract. So now I have 2/4 plus 1/4. Don't ever do that again. 3/4. God, that hurt. Okay? Now, when I say you got to use parentheses, it's very important. What happens if I switch this up, came all the way back here, but instead of 1/2, I said y was -4? What's -4 squared?
16.
Type it in your calculator.
No, it's just.
Type it in your calculator.
No, that's. -4 squared. Oh, it's just -16. Which technically, how's it just be 16?
There you are. What is it? Okay. Some of us are going to get 16. Some of us are going to get -16. If you do not have calculators, there's a class set of the graphers back here. If you are not comfortable with or have not used graphing calculators in the past, you're going to get real good with them after this class. Okay? I still recommend that you get your own at least scientific calculator. Probably the TI Inspire. It's basically Skynet. Oh, y'all making me feel old. Skynet was the artificial intelligence that took over the world in Terminator. Okay. TI Inspires are usually running about 140, 150. Yeah, don't do that. These, however, are $10. And they will do everything through calculus except the graphing. This is worth every penny. If you got 10 bucks, give me 10 bucks and here you go. I just robbed a shelf at Walmart. Okay. Well, okay, I paid for it, but like I just grabbed the entire box and threw it in the cart. Okay, same goes for notebooks. You are going to do so much graphing in this class. You need graph paper. Don't wing it. Don't have to ask. Throw your phone down, go. Okay. Now, I said some of you are going to have different things here. If I type -4 squared, really? Come on, Frank, wake up. -4 squared. But wait a second. What does it mean when I square -4?
-4 times
-4 times -4. Well, negative times negative is positive. Why is this saying -16?
because it probably
Remember I said negatives and exponents, you're going to screw them up. This. You say the calculator is wrong. The calculator is not wrong. It is performing the order of operations. Order of operations, this is read as -1 times 4 squared, and exponents come before multiplication. So if I want the 4 to be negative, I need parentheses to square it correctly. Okay. I need parenthesis -4 parentheses squared. Now it's good. I want to drive this home now because it's one of the most common and easily avoidable errors in algebra. Okay. So I just wanted to talk about that just in case. I want you to come down here, do 3A. And then y'all next to someone, talk about B. Do 3A, talk about 3B. Like, no joke, I know sometimes you guys just can't get over to the store, so I have a stash of calculators and notebooks. If you have the money for it, great. If you don't, come talk to me on the discreet. We got Spartan time next hour. Okay? That's the future elementary teacher right there. The color-coded note cards in their own case. That's the future elementary teacher right there. That is beautiful. I love it. 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 What happened is I called her out and embarrassed her, and now she's turning beet red. I'm sorry.
I get 18. 18. Yeah. You didn't have to buy it like 3? I did. I was like, yeah, 54. And I was like, what? Yeah, 54. Like 3. I was scared. Straight math. Yeah.
If you do it correctly, you should end up with the United States age of majority. Age of majority is the age where you are legally an adult. Okay. Ironically, everyone's all like, well, the age milestones of legality are end at 21. So why would I care about anything after 21? Not true. You can't rent one of those big 15-passenger stalker vans until you're 25. Yeah. Because it's something to do with insurance purposes. Like, it should be requiring a Class B license. So they need a minimum Class A license and a and age 25 because of their insurance. I found that out the hard way when I ran the group home in Arizona. They wouldn't let me rent the van. I ran the place and they wouldn't let me run the van. Okay. 2, parenthesis. Do not use that parenthesis. Replace the x with parentheses. Replace the y with parentheses. That's always why I do mine kind of big and small, so I understand which one's which. Okay, who in here has just got the trash handwriting? Like, the ability to do the big and then the small right after it, that's just not happening. Okay? All right. Find a system. That system might be, instead of this, you know that you're going to have parentheses inside of parentheses. What can you do? Brackets. You can change this into a bracket. You can always do that if maybe your handwriting is just not enough to distinguish that. Okay? So we do all this. We toss in a 6 and a -3. Hey, cool, the -3 is in parentheses. Now here's another reason that I say everyone should have, at a minimum, a right view calculator, a scientific right view calculator, is because I can now take that and I can type it exactly as it's written. 2, a parenthesis, a 6, a parenthesis squared, minus a parenthesis, a -3, a parenthesis squared, arrow down. 3. Oh, forgot mine over here. There we go. It wasn't going to change it, but still. Okay. This is what's called a right view calculator because I can type it exactly as it's written. Those $10 calculators over there. They are right view calculators. Not only will they be able to write it just like this, they'll simplify fractions for you. They'll simplify radicals. Do y'all remember simplifying radicals? Mm-hmm. In this house, we write things in simplified fractions, radicals, terms of pi, I, and e. You don't give me decimals in this house. You write it correctly because otherwise you are getting rid of part of your answer. So that right view calculator might be worth it. I have, I think, a small handful that were donated to us that I can part with for kids who are having trouble with the resources. If you have the resources, drop me $10 for a calculator, $1 for a graph paper notebook. That's what I paid at Walmart. I just got them here for convenience. Speaking of convenience, Game Club appreciates your business. There's Pop-Tarts in the pantry right there. You throw $1 in the cup and you get it. There you go. You got Pop-Tarts. This is how Game Club makes our money. I sell junk food to impulsive teenagers. Okay? Like, did I show you all that yesterday?
What flavor on it? Oh my god. What flavor are they? Wasn't there like a
Fudge, s'mores, strawberry, brown sugar, cinnamon, blueberry, cherry. Down here, I got a bunch of chips and cookies. Throw $1 in the jar and you're good. I'm not joking. Like, this was Game Club's fundraiser for 5 years. I don't care if you're in my class or not. You're in another class. You walk out to go to the bathroom, wander in, toss $1 in there, grab a Pop-Tart, and leave. Okay? So, y'all, I'm not making money on kids. Any profit from this is Game Club. We use it to buy games to play. All right? So, like, nerds. Yeah. So, down here, part 3b, what's going to change if I remove the parentheses? Oh, I suppose I didn't actually say the answer. It is 18, right? Okay. If I remove the parentheses, let it begin. If I remove the parentheses, now 2 is only multiplying the x squared. right? 2 is only multiplying x squared if I get rid of the parentheses. That y squared will not be doubled. Let it begin. Let it begin. All right. Okay, so we all went through that. Let me double check where we got to end today. I got to see a thing. Okay, 6. Yeah, we got time. I'm going to show you a thing because I like trolling this kid. As we're over here talking about Pop-Tarts and sharing and all that business. So Game Club sometimes goes through phases of making their own custom magic cards. I want you to pay close attention to the flavor text at the bottom. This kid was friend zoned so hard. And he bought these 2 girls Pop-Tarts every day. They milked him for it. With a face like that, how can you say no, right? Yeah, so that was a thing. No, not you, not you. There we go. Okay. So I just had to toss that out. Writing and evaluating. So now we're going to combine them. You know how to evaluate. You know how to write. Put them together. I do some. You do some. I show you example. You run through one similar. In the foosball, American football, because we are the only ones in the world who call it that. A touchdown is worth 6 points. Extra point kick, 1. Field goal, 3, assuming no safeties. Although, if we're talking about our football team, there's probably safeties. It's hard to sustain soccer and football at the same time, right? Take all the fast coordinated kids away from football, what do you get? A bunch of guys like me, right? So, what algebraic expression models total number of points that they score, assuming it's one of those 3? Stop right there before even reading the rest. Total number of points. What am I going to be doing? Okay. Assuming it's one of those 3. So the first thing I'm going to do is say blank plus blank plus blank. I can remove the blanks later, but I'm going to do that right now just to wrap my head around it. Okay. It's one of those 3 types. How many points do you have? It's one of those 3. I don't know how many of the 3. So that means if I don't know how many extra points, how many touchdowns, how many field goals I have, what's going in there? Variables, and then I will multiply based on their value. So I'm going to use, well, there's a conundrum. What do I use as my variables? No, we can't use turds for all of them. Okay. I should probably use something that matches with the context of the problem, right? So let's say that many T's for touchdowns. How much is a touchdown worth? 6. Okay. Plus, an extra point kick is worth 1. X for extra. Okay, I like that. And it's 1 point for it. What do I not need to write? Right? The 1 in front of it it's redundant. Like if I have just a plain old X floating out there, technically, There's a 1 as a coefficient, a 1 as an exponent, a 1 as a denominator, and then a 1 as an exponent of the entire thing. Theoretically, I could say there's a first root of. It's all there, we just don't write it, okay? And then a field goal. F? F's in chat, F's in math. Okay, how many? Okay. So now I have the expression, and then Brooke, right? Hey, I win. Okay. What Brooke had said before, what if we don't define the variables on the test? Did I put it in the instructions? I am telling you right now, define your variables. I don't know what T and X and F are. I have no idea what those are. So off to the side, I'm going to make sure to write T is number of touchdowns. I'm going to say X is number of field goals. I'm going to say, oh no, wait, that was my extra point kick. Extra, that's right. Extra point kicks, and F is number of field goals. Okay, even those are abbreviations, but those abbreviations are in the problem, so it's okay. Now that I have that, we hit the question. What is the expression that does this? Cool. Now that I have the expression, suppose they score 3 touchdowns, 2 extra point kicks, and 4 field goals. How many points did they earn? More than Spearfish.
Probably.
6 by 3 plus 2 extra point kicks. And 4 field goals. Okay. No, I genuinely believe that our school isn't quite big enough yet to sustain soccer and football at the same time. Like
Soccer, they got that a lot.
Look at our football team.
Like our soccer team doesn't get easy.
But no, seriously, what happens when you have 2 concurrent sports and one of them takes a large percentage of the fast, dexterous kids? That's your skill positions. Those are your skill positions. Those are your running backs. Those are your receivers. Okay? Should they be there or should they be at tight end? Should they be at D-back? Okay. Let's see what you guys got this year. Okay?
Right now it's on big.
Because right now we're like
Basically,
only 30 classes.
we got our skill players.
Okay.
Actually, they're all little. We're all.
Well, then go out into the hick lot with a bag of donuts and say, "Hey, bud, we need some O-line." Okay. Anyway. My high school, we were small. I had a graduating class of 52 and we broke the school record. Okay? It was not a big school, but we were actually decent size for the area because we were still 11 man, not 9. My senior year, our starting 5 O-line averaged 270 or 275 pounds. That was the hog line right there. You ain't getting past that. I was, what was it? I did a lot of offensive, defensive tackle. Senior year, I got moved to middle backer and then got knocked out too much, so I had to quit. I could not multitask. So when I was middle backer, it was, all right, this is your box. Yes, coach. Kill anything that comes in the box. Gotcha, coach. What about like calling out strength and pass protection? Dude, you can't do that. You're not coordinated enough for that. Just kill anything that comes in the box. Gotcha, coach. That's all it did. But then that was also like 18 years and about 82 pounds ago. So do that. Do that. I'm off topic. Do that. It's the exact same thing, but now we're talking about basketball. The wiggle what?
I know, that's what I heard too.
20 plus 15. That's 40.
Okay. Yep. Oh yes. Define your variables. Define your variables because you got multiple things here. If you don't have a definition for which variable is which, like if you only have one variable, you probably don't need to define it. But if you have multiple variables, you should define which is which. Remember, talk it out. Chat it out with your neighbors. Argue. I'm a big dude. Could you move this back a little bit to where it was? I just don't want to trip over your feet and like come over here and get the accidental graze and end up on CNN or something. Yeah. There we go. Good cross chat.
How many sections do we get through a day?
Meh. We go until we go. Normally it's one a day. There's going to be some sections that are just too tough and it takes us 2 days. Okay. Okay. I might do mine differently than you. That's okay, so long as you define your variables. What I'm going to do is be ultra lazy about this because they're defined based on their number of points anyway. I'm just going to say X is free throws because they're 1 point. Y is going to be your general basket at 2 points. And Z will be my 3-pointers. That's what I'm going to do. It doesn't have to be what you do, so long as you define your variables. And I'm going to say, well, I can have this many free throws worth 1 plus this many regular baskets worth 2 plus this many 3-pointers, clearly, worth 3. Okay? To me, that's nice and clean. 1, 2, 3. X, Y, Z. Doesn't have to be what you had, right?
Correct.
Who had a bunch of F's and T's and D's and what all in there, right? Cool. If you label them, you're good. So then we say this plus 2 of that plus 3 of that. And what algebraic expression models it? Check. If a team makes 10 of those, 5 of those, and 7 of those, what do they got all together? I see 7, 20, and 15. Meaning of life, 42. I mean, 42 points in the game. Girls JV.
Yeah, that's what I've done.
No, probably
C squad.
girls varsity.
There's a kid a couple of years ago, graduating a few years back, named Maddie. She wasn't tall. She was a decent shot, but she was physical. Maddie Gould.
Oh,
Oh, she was physical. When she got injured, the team was toast because she was just in it. She was always in someone's face, always moving. She was the one that grabbed that ball and just send some girl twice her size flying. It was great. No, this this is basketball. She was just incredibly physical. It was, gosh, she was good. But is she still over at Common Grounds?
I think she's in college.
Who's that girl?
No. Oh, okay. I run into her every now and then, and I put the tip on the. You always have the check amount, and then they give you the subtotal, and then they have the tip, and then the total.
Yeah.
I'm that guy that does. Oh, that's right. This is Algebra 2. You don't know what E is yet. Okay. This is $9, by the way. But yeah. Yeah. I only do that if I know they're not going to spit in my food next time. So don't do that to a normal person. They're going to spit in your food. But yeah. More vocabulary. Terms. A term is anything that is separated by addition and subtraction. Has to be separated by addition and subtraction because multiplication smashes things together. Okay? We always say, what happens when you smash something up against parentheses? Well, like rabbits and hormonal teenagers, they multiply. Okay? At least that's what my teacher taught me. I don't know how it works around here. Well, maybe in South Dakota it's different, but okay. A term is anything separated by plus and minus. So how many terms are right here? Okay. Do you remember ever chopping them up like this?
Yeah.
And kind of like making boxes around them so you can just move the boxes around to combine like terms? It works for some kids. It doesn't work for everyone. Okay. So there's 3 terms here because there's 3 things separated by plus and minus. These numbers in front of variables, smashed up on a variable, tells you there's 7 of these. There's 4 negated of these, the opposite of 4 of these. Those are coefficients. Constants. Well, these are called variables because their value can vary. It can change. I can put different things in there. But 6 is 6. It doesn't matter what's going on. 6 is just 6. So in that case, it is a constant because it does not vary. Okay, so I have a variable, a coefficient, a constant, terms. This is just basic vocabulary you've done a long time ago. I just got to roll through it just in case. Because we talk about like terms. To be like terms, it's got to meet a couple of conditions. Number 1, what do you think? They have to have the same variables. What else? Same exponents. There is a third rule. Okay, no. To combine. I like this, okay? I see kids who will try to combine terms across an equal sign. That equal sign is like the electric fence of doom. That's the fence the little kid from Jurassic Park got zapped and went flying across. Okay? You can't combine like terms across an equal sign. Not bad, okay? But why could I not combine this with this?
There's 2 different variables. Has to be the same.
No, that's a Y, that's a Z.
The order has to be the same.
Okay. Same exponent has to be on the same variable. Same exponent has to be on the same variable. And the reason for that is this says 7 times y times z times z times z, whereas this says 9 times y times y times y times z. You see, if I break up the exponent, those are obviously not the same thing. So same variable, same exponents on the same variables. So to combine like terms, the way I always did it with my kids all the way back into pre-algebra is every time I run to a plus or minus, I chop it up. And then it's just like sorting Legos. The 2x4 plates go with the 2x4 plates. You don't put the 1x8 plates with the 2x4 plates. That's just madness. Okay? These two go together. I have 8 of these things. Do not, put that in here, okay? Put a little note off the side. Exponents do not change when adding and subtracting. You're saying I have 3x squareds plus 5x squareds. I don't now magically have 8x to the 4th. Okay? Like 3 medium pizzas plus 5 medium pizzas is not 8 larges. Okay? So I put those together and I got 8x squareds, a y cubed z, a y cubed z, 9 things minus 4 things is 5 things. And then, personally, I've always crossed them out as I hit them. What do I do with the cheese stands alone over here? Just kind of toss that at the end. Everybody hurts sometimes. There he is. Also, I apologize. I always make my z's with a line, but you'll notice as I'm writing, I'll switch between 2 and 2 like this. I'll switch back and forth between them, and I don't even know why I do it. Z's always have a line in it. In fact, Z's have a line, T's always have the tail. S's usually get the extra line next to it. Technically, that means suppose in mathematical proof, but I'll at least do that so I know it's an S and not a 5. Okay. I will always alter my letters in some way so I know it's not a number. But if you're ever not sure, ask. I want you to interrupt and ask when there's something you're not sure about. Okay. All right. Simplifying, right? And then, yeah, we're good. We're good. Okay. Here we go. Combine like terms. You probably all remember from geometry, this is how you very first learned proof. I say the P word and everyone's like, no! I will run you through a small number, maybe 3 or 4 different proofs in the class. You are not required to reproduce them, but you got to know them. Now, here's the thing. With math, once you hit a certain point, there's no more, I'm just learning new ways to move things around. Once you hit a certain point, math is only proof. Proving things in mathematics. Once you go past pre-calc, in trig, you do a lot of proofs. They're called identity proofs, where you take this big honking thing that's got a bunch of sines, cosines, tangents, secants, cosecants, cotangents all over the place in it, and you're supposed to use identities to prove that it's actually just cosine minus 1. Okay? It's simplifying expressions is what it is. You're using the proof nature to simplify an expression. You go far enough, it's all proof. In here, we're only going to do a tiny bit, and it's more just an example. But do you remember that. Okay. In our book, this part, I left it there so you would see sometimes they will write it out like this in the book. They will show you why it's doing that. More appropriately, sometimes in the solutions, they will show you that, so you know why. But other times, this is not here. I wish they would give me a bigger marker than that. Okay, other times that's just gone. It's not there. This is how the solutions look. I showed you all the solutions on our Google Drive folder, right?
Yeah.
Our homework tonight and every homework assignment you do for the rest of the year, the solutions are already in Google Drive. I want you to use them. If you're just copying them to make it look like you did your homework, you are screwed when it comes to a test. A lot more. So don't do that. But you need to know how to read the solutions. If this wasn't here, could you go through this and understand what they did at each step? How'd they get from here to here? It's the exact same thing. They just made it pretty colors. How'd I get from here to here? What changed? They moved the order. The property that says order doesn't matter is commutative property. Shut your holes while I'm talking. Come on now. Each one of these has a step. You have to be able to follow from one step to the other. They don't always put y next to it. I just want you to be aware of that. So let's come down here. Y'all remember what the first stage is to combining like terms and simplifying an expression when I got parentheses up in there? What's it mean when something is smashed up against parentheses? You multiply. Distribute, because that multiply is up on parentheses, so it's going to multiply everything inside. Y'all remember probably doing the little rainbow thing? That's a negative 3k. That's a minus m. That's a plus 2k. That's a minus 8m. And then, womp, womp, womp. Which of those boxes go together? Do I have any other something k's? Sure do. You owe me $3, you borrow or you pay back 2. You still owe me 1k. You owe me $1, you borrow another 8. You now owe me 9, right? -1 plus -8 is -9. Okay? Distribute, combine like terms. So, I do some, you do some, get them. You know you turn these in, right?
Mm-hmm.
Okay. So,
What's up?
No, I was just.
that was a very specific stretch. Yeah.
For this problem here, would I distribute with the -2, or would I just leave the negative and then do?
The negative is attached to the 2, yes. It's either you distribute a 2, but then you have to subtract each term, which we sometimes forget to subtract the ones at the end, or just distribute a -2 and be over with. Yep.
Let's just do the negative on that side.
Okay. On the first one, you owe me 4 things, you give me a thing. You owe me 3 things. Right? Exponents do not change when you're adding and subtracting. Do not try to combine these together and say there's now negative 2 kj's. They don't have the same variable. Is it the same person? Who is that?
Oh, that's bracket.
I swear, Mom, I didn't do it. You just got to tack them on the end. There's nothing to do with them. Okay? There's nothing to do with them. I can't combine them with anything else. On the next one, I distributed a -1 and a 10 respectively. Now, A's go with A's. B's go with B's. Almost like diagramming sentences again. Okay? Now, some of you already jumped onto this side and started doing stuff. You notice that little thumbs up in the corner? You know the whole Roman tradition of thumbs, right? First of all, we have that backwards in our pop culture. This did not mean they live. This meant kill them. Like, the crowd wanted blood and guts in the Colosseum. So if he was like this, he's like, hey, should we get him? Huh? Should we do it? Yeah. Or, no, don't do it. Okay? But everyone does it opposite. Like the actual movie Gladiator, this was kill them, right? So we have that backwards. I do it as a visual confirmation. I told you that I'm very visual spatial. If I ask, how are we doing? Do we have any questions? The majority of teenagers aren't going to say anything. But if I instead, every time we hit one of these pages, say, all right, show me thumbs, it's easier for someone to say, I get it. I'm a little fuzzy. I could probably use 1 or 2 more. I have no freaking clue what's going on. And it's a lot easier for someone who might not be comfortable speaking out about that to just kind of do one of these. And if I see 1 or 2 kids even doing that, I know that there's easily twice that number who just aren't being honest. And I'm going to do more examples. Okay? Now, if I did something big honking like this, I think we're okay with order of operations. Hopefully, right? Replace the K with parentheses and then just go. But I'm betting we might have trouble simplifying this. I want you to try it. I want you to argue with your neighbors. I want you to try.
Well, you can add.
Okay.
That means nothing.
Say that again?
That means nothing.
You distribute before you that box.
Is this resignation or confidence over here? Resignation it is. At least try something. Okay, for everyone who's staring at it, just saying, what the flying fornication is this?
actually what you meant to say.
In front of every one of those y's is a 1.
So then when you multiply the same color.
Could that somehow allow you to rewrite each one of those fractions? That's why I always say no ice. I'd rather have lukewarm pop than a puddle. Um,
4y minus
Okay.
3y.
you know the fraction shortcuts on there? The alpha windows?
No.
Alpha, all this stuff brings up shortcut menus. There's your fractions. Regular fraction, mixed number. Change a regular fraction into a mixed number. Change fractions into decimals.
Are we gonna use
A lot. Different types of functions, the most common functions that we use in this class.
Does yours also have this too?
Yes.
I'll probably be coming in and saying,
Matrices, which we do not use. We will use this for our regression models.
okay.
So you're set.
Hey bro, are you done?
Same thing, just not pretty.
Did you sync with the VR?
Y'all, if that's a 1 in front of y squared, isn't that the same thing? Right? Because 1/4 times y squared is 1/4 times y squared over 1. Okay, everyone who's arguing about the thing that I'm showing you the thing, you probably want to look at the thing. If there's a 1 in front of this, I can rewrite it as a coefficient of y squared. Because, if you remember how multiplication of fractions work, I multiply straight across. 1 by y squared is y squared. 4 by 1 is 4. Y squared over 4 is 1/4 y squared. Which nicely goes with 1/3 y squared. 4, 3, 5, 7, 12 y squared plus 3, 5, 7, 5, 8, 15th y. Oh, wait, that's add, and that's subtract. Sorry, this one's subtract, this is 2. It's always through Remind. I always send out the homework through Remind.
Me and Dawson will be done tomorrow for football.
Live stream, Haas. Just watch the video whenever you can.
Where do you find that video again?
The link is in Plan Book. I send it on Remind. It's also on the channel. It's in lots of places. Okay? You can also wander down during Spartan time if you want.
I will not be here tomorrow.